You are welcome back to this channel. So in today's class, I want to show you how we can use matrix method in solving simultaneous equation. So in simultaneous equation, we know that we are looking for unknown values. So here, use the matrix method to solve the simultaneous equations. 2x plus y is equal to 10, 4x minus 2y is equal to 4. So here we need to write these equations in the matrix form. So write in the matrix form. That means you'll be writing the coefficients of x and y. So you write them in a rectangular pattern. So we have 2, coefficient of x there is 2, coefficient of y is plus 1. Coefficient of x in the second equation is plus 4, and coefficient of y in the second equation is minus 2. So we use it to do that. Then the unknown values x and y, we write them like this. That is the column matrix. So it is equal to their values 10 and 4 is also a column matrix. So now let's A to be equal to this matrix 2, 1, 4, minus 2. And let x be equal to x, y. And let B to be equal to 10 and this 4. So from here, we can now write this. Let's call this one matrix 1. So this matrix 1 becomes matrix equation 1. Matrix 1 becomes, so it becomes, so we have A. Now we have represented this matrix by A. So and here is X. So is equal to B. Now, and what we want to find is X. That is, we want to find the value of X and Y. So how do we go about that? So to find X, we multiply both sides by inverse of A. Multiplying both sides by A inverse gives the following. Now, that means I'm multiplying A inverse by AX. Then A inverse multiplied by B. So you have to recall or you remember that anytime I multiply a matrix by its inverse, I will always have an identity matrix. I explained that when we were doing inverse of matrix. So anytime you multiply a matrix by its inverse, you are going to get an identity matrix. So here I can now say that this equation, let's call it equation 3. So equation 3 becomes Ix is equal to A inverse B. You need to remember also that if you multiply any matrix by an identity matrix, you are going to get back that matrix. So that means I can easily say that this is still X is equal to A inverse multiplied by B. So what do I need to find now? I need to find the inverse of A. And to find the inverse of A, the first thing that you have to do is to find the determinant of that matrix. If you find the determinant of that matrix, it is the one that will let you know whether that matrix has an inverse or not. If the determinant of that matrix is equal to 0, that means it doesn't have an inverse. But if the determinant of that matrix is not equal to 0, it means that it has an inverse. So here now, I'll now say that determinant of A is equal to determinant of 2, 1, 4 minus 2 is equal to, you multiply elements in the leading diagonal together, so we have 2 multiplied by minus 2 gives me minus 4 minus those elements in the second diagonal will be 4 multiplied by 1, and that is 4. So the determinant of this A is equal to minus 8. So that means this matrix A has an inverse. So after doing that, you can now come here and find its inverse now. And its inverse will be 1 divided by the determinant of A multiplied by, now go back to that your matrix. So the elements in the leading diagonal, let them be interchanged. You change them, you want to swap them. So that means this minus 2 becomes the first element and 2 becomes the last element of that matrix. So what we are going to do again is that those one in the second diagonal, that is here, we are going to put minus on top of them. So this one becomes minus 1 and here becomes minus 4. So now your inverse will now be equal to A inverse is equal to 1 over minus 8 can give me minus 1 over 8 multiplied by minus 2 minus 1 minus 4 2. So I can now multiply. This one serves as like a scalar, something now. So I use it to multiply everything inside now. So I have minus 1 over 8 multiplied by 2 gives me 2 over 8, and 2 over 8 is equal to 1 over 4. So minus 1 over 8 multiplied by minus 1 gives me 1 over 8. Minus 1 over 8 multiplied by minus 4 gives me 4 over 8, which is 1 over 2. Minus 1 over 8 multiplied by 2 gives me minus 2 over 8, which is minus 1 over 4. So that is the inverse of matrix A. So now to find x now, I'll now go back to this equation. X is equal to A inverse multiplied by B. So now my x will now be equal to A inverse A is what? 1 over 4, 1 over 8, 1 over 2, minus 1 over 4. Then multiply by B. Our B is 10, 4. So let's multiply. So use one, this in the first row of the first matrix A, you use it to multiply the first column of the second matrix A. So 1 over 4 multiplied by 10 gives me what? 10 over 4, and that is 5 over 2. 5 over 2, then plus 1 over 8 multiplied by 4 gives me 4 over 8, and that is 1 over 2. Then you do the same thing for the second row of the first matrix. So 1 over 2 multiplied by 10 gives me 10 over 2, and that is 5. Plus minus 1 over 4 multiplied by 4 gives me minus 4 over 4, and that is minus 1. So minus 1. So this gives, if I find the LCM of this one, I have 2. So I have 5 plus 1. So then here I have plus multiplied by minus gives me minus. So I have 5 minus 4. And 5 minus 1, and that is 4. So here this becomes 5 plus 1 gives 6. 6 divided by 2, 3. And here is 4. So that means the value of my x, which is x y, is equal to what? 3 and 4. So thus the solution of that equation will be x is equal to 3 and y is equal to 4. So please go through it. Let's solve another example. Use the matrix method to solve the simultaneous equations. 7x minus 3y minus 20 is equal to 0. 3x minus 5y minus 3 is equal to 0. Solution. The first thing is that you have to rearrange this thing so that it looks like this. 7x minus 3y is equal to 20. Take this minus 20 out, it becomes plus. That is my equation 1. So I have 3x minus 5y is equal to 3. So that is equation 2. So from here, let's write in a matrix form. So I have 7 minus 3, 3 minus 5. So let that one be my A. So then, don't write that, yes. So I have x, y is equal to 23. So now, I can now say that let this one be my A. So A is equal to 7 minus 3, 3 minus 5. And my x is equal to x, y. And let b be equal to 23. Then from here, I can now rewrite this matrix 1 or A or anything as what? A multiplied by x is equal to b. So don't forget, multiply both sides by A inverse. So I have A inverse multiplied by A x is equal to A inverse multiplied by b. And A inverse multiplied by A gives us identity matrix. Identity matrix multiplied by x gives us x. So I have x is equal to A inverse multiplied by b. And to find my A inverse, I need to find the determinant of that A to determine whether it has an inverse or not. So determinant of A becomes 7 minus 3, 3 minus 5. That will be 7 multiplied by minus 5 minus 35 minus 9 multiplied by minus 3. That is minus 9. So this gives minus 35 plus 9. And that is what? Minus 26. That is minus 26. That means the determinant of A is equal to minus 26. Now let's find the inverse. The inverse of A will now be equal to 1 over minus 26 multiplied by, we interchange this one. This one becomes minus 5, here becomes 7. Put minus minus on top this one. So this one became 3. This one becomes minus 3. So that's the inverse. So let's simplify it. So I can have 5 over 26, then minus 3 over 26, 3 over 26, minus 7 over 26. So that is the inverse of that matrix A. So after that, I can answer that my x is equal to A inverse multiplied by B becomes A inverse is 5 over 26 minus 3 over 26, 3 over 26 minus 7 over 26, then multiply by B. My B is 23. So x is equal to, when I multiply this one, 5 over 26 multiplied by 20 gives me 100 over 26. Then plus minus 3 over 26 multiplied by 3 gives me minus 9 over 26. Then followed by here 3 over 26 multiplied by 20 gives me 60 over 26. Plus minus 7 over 26 multiplied by 3 gives me minus 21 over 26. So this is equal to 100 over 26 minus 9 over 26. Then here I have, this one is minus. So 60 over 26 minus 21 over 26. So x becomes, here we find the LCM is 26. Then since they are having the same denominator, so that will be 26. So that means I can easily subtract the numerator from each other now. So this will be 100 minus 9, that is 91. Then here also we have the same denominator, 26. So 60 minus 21, that is 39. So here 13 can go in 91, it can also go in 26. So it goes in 91 7 times, it goes in 26 2 times. So 13 can also go in 39 3 times, it goes in 26 2 times. So, and recall that my x is equal to xy. So that means is equal to 7 over 2, then 3 over 2. So I can easily say that my x is equal to 7 over 2 and my y is equal to 3 over 2. So very simple. Please go through everything. So till I see you in the next class. Thank you. Bye bye.